we're going to learn about in normal distributions. Okay, normal distribution is a bell-shaped distribution. It's symmetrical about the mean. Right, here's our mean. The mean and the median are the same. Right? That's part of, if it's not skewed, if it's not somehow or other not symmetrical, that's another thing. But a normal distribution, a perfect normal distribution, mean and the median in the same place. Shape on the left side, same as the shape on the right side. Can anybody tell me what percentage of the population is on the left of the mean? What percentage is on the right of the mean? I got an opinion there? 50%, right. 50% is to the left of the mean. 50% is to the right of the mean, or median, right? Mean and the median are in the same spot, same number. Okay, so now if I told you that the mean here is equal to 100 and the standard deviation is equal to 10, right? An interesting property of a normal distribution is that we can define the shape of this normal distribution based on these two numbers. Okay, so now one of the common properties of all normal distributions is that if you look at the value that's one standard deviation below the mean and one standard deviation above the mean, right? Well, that area represents 68% of the population, or 68% of a random sample of that population, normally distributed population. Does this ring a bell to you guys? Yes, no? Right? Probably came up, right? That's called the empirical rule. Exactly. Okay. So now, what value is one standard deviation below the mean for this distribution, one standard deviation above? Well, since the mean is 100, the value that's one standard deviation below is 90. Value that's one standard deviation above is 110. So 68% of this population is between 90 and 110. Well, now what if I looked at two standard deviations above and below the mean? What percentage of the population is going to be between those values? Any opinion? Right, 95%. Okay, so what does that leave in this upper corner here? Right? What does that leave left that's more than two standard deviations above the mean? That's 2.5%. Since this is symmetrical, there's only 5% left. 2.5% is here, and 2.5% is here. So standard deviation is 10. That would be 120 and 80. And 80. So 95% of the population would be between two standard deviations above and two standard deviations below would be between 80 and 120. So if I actually asked you what percentage of the population was above 120, you would say 2.5%. If I asked you what percentage of the population was below 80, you would say 2.5% is below. Correct? Okay, so now I'm not now if Leonardo, I think you're thinking of 3 standard deviations below and 3 standard deviations above. That would be 99.997, I think, right? 0.993 or 0.9, I think it's 0.997, right? Or 99.7, right? So that would represent 3 standard deviations above and below. Now, if I were to ask you what percentage of this population was above 110, what would you say? Well, above 110, that's this area in here. That's the area to the right of one standard deviation above. Well, we know that this whole area from here out, let me change colors here. We know that this whole area here, this is what we're looking for, this whole area here, right? Well, we know that the area between here and here is 68% of the population, right? So since this is symmetrical, this must be 34% on this side and 34% on this side, right? So that means from here to here is 34%. And since the right side of the mean has 50% of the population, and this takes up 34%, that leaves this area over here to be 16%. Okay, everybody okay with that? Okay, if I asked you what percentage of the population was below 80, you would say, oh, well, that's over here. That's 2 standard deviations below the mean. Okay, well, 2 standard deviations below the mean is going to leave 2.5% in here. So 2.5% of this population is below 80. Okay, now if I asked you what percentage of the population was between 80 and 110, well, what would that be? Well, this area between 80 and 110, I'm going to change color again. Okay, let's change it to this light blue. Okay, that would be this area in here, right? And we know that that area is 34%, right? Because it's half of that 68. And this area in here, right? Well, this area in here, well, that would be 50% less than 2.5%. So that would be 47.5%. So what area of this distribution is between 80 and 110? Well, it's 47.5% plus this 34%, right? So it's going to be 81.5%. Okay, so what have I done here? I've kind of monkeyed with this empirical formula to help me work out uh, 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 things that I can learn about this, to ferret out information about this normal distribution that weren't obvious before I started applying this empirical rule. Well, does this just work with this? Well, no. It'll work if the mean were 75 and the standard deviation were 7, right? You'd just get a different shape. It'd still be symmetrical, and all these rules would still work for whatever numbers are 1 standard deviation and 2 standard deviation. The real key here is that that these percentages of area will always hold up for normal distribution. Okay. Now, at some point, we're going to learn about something called the z-score. I don't think we got to that in the lectures. I know some of you probably remember that from another course, but I don't believe that, I don't remember hearing that come up during the portion of the lectures that I actually saw. Did you guys cover anything on the z-score in any of the lectures that you remember? I don't got a response either. Yours, yeah, no, I don't think it can. I think empirical formula came up, but I think next week is probably we're going to start really kind of hammering on that z-score. And that z-score, the z-score is just the number of standard deviations. You can actually empirical formula. We can only really work with what we know about 1 standard deviation above, 2 even numbers of standard deviations above and below. The z-score allows us to note this information even more precisely by using tables that give us precise areas of a normal distribution for any number of standard deviations, whether it's a whole number like 1 standard deviation below or 0.967 standard deviations below, what that area represents in the normal distribution. Okay, so I think, I don't know if this will come up on the test. If it does, you have a little bit of a preparation for it. But I think we should be in pretty good shape.